Good evening, everyone. So, Gautam Sarma, I welcome you all in a Sapiens Education. So, today I am going to discuss about the question number 9.16 of NCERT. The chapter is fluid mechanical properties of the fluid. So, let us discuss. The cylinder tube of a spray pump has a cross-sectional area of 8 centimeter square at one end and which has 40 fine holes, each of diameter 1 mm square. If the liquid flow inside the tube is 1.5 meter per minute, what will be the speed of the ejection of the liquid through the hole? So let us discuss what is the situation. So spray, the spray of the pump. So let us consider. Let us draw the structure. So let it be that there is a sprayer, and one side the whole liquids are coming inside it, and another side there are several holes opening. Now the liquid has a velocity that is initial velocity v1 is equal to 1.5 meter per minute. Okay, and final velocity we don't know, we need to find out. See here, what is the speed of the ejection? But the area a1 is given as 8 centimeter square. Now what a2? So a2 is equal to what? Since they have given there are 14 holes, the holes is like this, there are 14 holes. So total area at the outlet, that is area at the outlet will be how much? So area at the outlet will be, that is a2 is equal to 40 holes in area of the 40 holes, that is equal to pi into r square. So r here radius is given as 1 mm. So diameter will be 0.5 mm, right? So you have to put here 0.5 into 10 power minus 3 whole square. Okay, so when we will calculate this, so we will get the value of A2 as 0.314 centimeter square. So we have got the area. Now we know that the equation of continuity A1 V1 is equal to A2 B2. Now here A1 is 8, or we can directly find A2. So A2 will be equal to A1 V1 by A2. So when we put A1, so A1 will be equal to 8 into V1 is equal to 1.5 meter per minute divided by 0.314 centimeter. So centimeter will get cancelled out and it is in meter per minute. Okay. So finally, if we do calculate, so we will get 38.217 meter per minute. So the area A2 will be equal to 38 meter per minute, because if we consider two significant figure, so we will get this. So finally our answer would be A2 is equal to, sorry, it is V2, not A2, it is velocity V2. So velocity V2 is equal to 38 meter per minute. I hope you have understood this question. Okay. Now let us solve question number 9.17. In question number 9.17, a U-shaped wire is dipped in a soap solution and removed. The thin soap film formed between the wire and the light slider support, weighing itna, which includes the small weight of the slider. The length of the slider is given. What is the surface tension? So let us draw the situation. So if you want to draw the situation, see here, there is a wire, and in this wire there is a slider. Okay, and in this slider we have a liquid we have a liquid layer. Okay, when you dipped it in the solution, so we will get the liquid layer like this. Okay, so there will be a liquid layer. Got it? Now there is a weight. So weight, and the weight or the force is acting is 1.5 into 10 power minus 2 Newton. So this is the weight. Okay. Now if we got the weight, then what we need to do here? We need to find the surface tension. As we know that if we see this cross sections, there are how many layers are there? Two layers are there. How many layers are there? Two layers are there. So due to two layer, we are getting a if we have a two layers, so we will get two force or double the force. It means that there are two surface forces there. So 2 into, or we have to put here 2 times the force. 2 times the force, or 2 times, what is the formula for the force? Force is equal to surface tension by length. So this is equal to 2SL. And this 2SL is countered by this force in downward direction. Force due to gravity. That is equal to 1.5 into 10 power minus 2 Newton. Now from here, we want to find surface tension. So surface tension will be 1.5 into 10 power minus 2 divided by 2 into length L. So what is the length of the wire which is slided? So this length L is how much? L is given as 30 centimeter. So where we can put here 1.5 into 10 power minus 2 divided by 2 into 30 centimeter. Okay. So but is it in a centimeter? No, we can't. It is better to take it into meter. It will be 10 power minus 2. Minus 2 got cancelled. 10 power minus 2, 10 power minus 2 got cancelled. So the surface tension will be equal to 0.025 Newton per meter. It is 2.5 into 10 power minus 2 Newton per meter. I hope you have understood this. Okay. So this is the correct answer. Now let us do question number 9.8, 9.18. In the figure, in 9.18, in figure shows a thin liquid film supporting a small weight 4.5 into 10 power minus 2 Newton. What is the weight? What is the weight supported by the film of the same liquid at the same temperature in figure B and C? Explain your answer physically. Now let us see here. As you see in the case of A, let us consider surface tension of the liquid is S, because all the liquid for all the three situation is same, so surface tension will be same. So force with each can it can withstand is equal to surface tension per unit length. So length is 40 centimeter for one case one. Length is also 40 centimeter for B and C case. So only depend upon force only depends upon surface tension and length, which is constant for all three case. Okay, hence in all cases it can support it can support force is equal to it can support force is equal to 4.5 into 10 power minus 2 Newton. I hope you have understood this, right? So let us do next question. Next question. In question number 9.19, what is the pressure inside the drop of a mercury of a radius 3 mm at a room temperature? Surface tension of the mercury at the temperature is 20 degrees Celsius is this, and the atmospheric pressure is this, and also give the excess pressure inside this. So let us draw the figure. What is the pressure inside the drop? So of the mercury, it is drop. So in drop, only one layer is in contact. Layer contact with the air. With air. Okay. So the atmospheric pressure or outside pressure, P outside is how much? 1.01 into 10 to the power 5 Pascal. Now the pressure inside, we need to find pressure inside. But inside pressure, inside there is whole liquid only. No layers are there. So inside pressure. So before that, we may need to find a excess pressure. We know that the excess pressure is equal to 2S by R for single layer. The layer with which it is contact with the air. So since it is the only one layer which is in the contact with the air, so we have excess pressure is equal to 2S by R. So 2 into S, as they have given as a surface tension, is 4.65 into 10 power minus 1 divided by radius. The radius is how much? 3 mm. So 3 into 10 to the power minus 3 meter. So when we calculate this, so we are getting 310 Pascal as a excess pressure. Now the pressure inside will be how much? Pressure inside plus P excess. Pressure inside is more, so pressure inside is equal to inside pressure. See, here we need to understand how we will find a inside pressure. Before that, we should understand this fact. P inside minus P outside, that is P atmospheric pressure, is equal to excess pressure. So P inside is equal to excess pressure plus P outside pressure. So excess pressure we have got 310 Pascal plus atmospheric pressure is 101 triple zero Pascal. So when we add this, so how much we are getting? We are getting 101,310 Pascal as an inside pressure. But if we look to the significant figure, so there are only 3 significant figure required. So we can write here 1.01 into 10 to the power 5 Pascal. Okay. So I hope you have understood. Now let us read the question number 9.20. What is the excess pressure inside the bubble of a soap solution of a radius 5 mm, given that the surface tension of the soap solution at the temperature is this? So they are asking about the bubble. So bubble, if we talk about the bubble, so the bubble has how many layer which is in contact with the air? So there are 2 layer which is in the contact with the air. So one layer creates a change in a pressure of 2S by R, and inside one layer also creating a pressure of delta excess pressure is equal to 2S plus R. So this is outside excess due to outside due to inside. So total excess pressure will be equal to 4S by R, 4S by R. Okay. Now 4S by R. Okay. Now if we put the values here, So how you will put in the values for the excess pressure? So this will be 4 into surface tension is how much? This is 2.5 into 10 to the power minus 2 divided by 5 into 10 to the power minus 3. So this is equal to 20 Pascal. Okay, so this is the excess pressure inside the bubble. Okay, if an air bubble of the same dimension were formed, now see here, what is the excess pressure inside the bubble? We have got the solution. So excess pressure inside the bubbles of bubbles of is equal to 20 Pascal. So this is the first part of the answer. Okay. Now if an air bubble at the same dimension were formed at the depth of 40 centimeter inside the container. So let us assume that there is a container. So there is a container. Let us consider there is a container, and in this container, the same bubble is inside down. It is below this, and which is at a distance of 40 centimeter. Okay, deeper. What would be the pressure inside the bubble? So pressure inside we need to find. So as we have studied that pressure inside will be equal to excess pressure plus P naught. So first of all, outside pressure is how much? Outside pressure. So let us assume that outside pressure P naught is equal to this atmospheric pressure plus rho gh. So this thing we know. So atmospheric pressure plus rho g into h. So the atmospheric pressure is 1.01 into 10 to the power 5 Pascal, plus rho is the density of the water. So density of the water is how much? It is given as 1.2 into 10 to the power cube into 9.8 is the gravity into height is 40. Not 40, it is 0.4. 0.4, it is in meter. Okay. So this will be 1.01 into 10 to the power 5 plus when we multiply it, so we will get 4.70 into 10 to the power cube. Now when we add this, before adding this outside pressure, before adding this, let us consider P outside is this. Now we also need to find the excess pressure inside the bubble. So excess pressure inside the bubble, since this bubble there is one layer of contact, so there is excess pressure is equal to 2s by r. We can't give here 2 4s by r. Why? Because there are only one layer, and this is the air, one layer which is in the contact with the layer. So excess pressure, how you will find excess pressure? So excess pressure is equal to 4s by, we have got the value 4s by r as 20 Pascal. So it will be excess pressure inside this case. This is totally different case. Okay, so you should make it separately. So excess pressure will be equal to 2s by r. So this will be equal to 10 Pascal, because 4s by r, we have got 4s by r. Excess pressure is equal to 4s by r. We have got 20 Pascal. So for the same case, if it is 2s by l r, so it will be 10 Pascal. So we have got excess pressure, we have got outside pressure. So we know that the inside pressure minus outside pressure is equal to excess pressure. So if we want to find inside pressure, so this will be P outside plus excess pressure. So the P outside is how much? So let us see here. P inside is equal to P outside. So P outside is how much? So P outside is 1.01 1.01 into 10 to the power 5. So this is 1.01 into 10 to the power 5 plus 4.70 into 10 to the power cube, 0.70 into 10 to the power cube plus 20 Pascal. Why 20 Pascal? Because the axis pressure is 10 Pascal. Sorry, for 10 Pascal. So we have to put here 10 only, not a 20. Okay. It's a 10 only, 10 Pascal. So finally, we need to add this. So how you will add this? See, 101 double triple 0. Another it is your 4700, and there is a 10. So when we add this, so this will be 501. Okay, but we required only 3 significant figures, so we can round off. So if we round up, so we will get 1.06 into 10 to the power 5 Pascal. So this is the pressure inside the bubble. So when we see and observe that the most of the time the pressure or excess pressure is approximately is equal to atmospheric pressure. So there is no drastic changes. So I hope you have understood this question. This also you have understood. So this is the part A question. This is part B question. So in part B we need to find inside the pressure inside. So we have got exact answer. So pressure P inside, again I am writing, is equal to 1.06 Pascal. Not a Pascal, it is a 10 per 6, 1.06 into 10 power 5 Pascal. So this is the answer. I hope you have understood this.